If you have a large or very dense level and you've been mindlessly clicking on build all levels, disregarding that the HLODs fail to generate, then this video is for you. My goal for this guide is to convey what I learned from diving into HLODs so you can set them up. That way you don't have to waste days or hours like I did, generating them with the wrong settings, running out of video memory or RAM. What made me look into it is that it took about 15 seconds every time I hit play in editor in a large map. Setting them up correctly smoothed up my frame rate and GPU performance. In a nutshell, hierarchical level of detail is just a way to define how your meshes behave when you're far away, and it's a way to increase performance. And as this documentation says, it's a way to combine pre-existing static mesh actors into a single HLOD proxy mesh and material, and how it combines them is depending on how you set up your HLODs. As an example, I'll be using the StackObot game sample, so if you want to follow along, navigate to the samples in your Epic Games launcher, and then I'll be using the StackObot. It's a small sandbox project showing a vertical slice. It's not exactly a large world, but it's perfect for showing how to set up the HLODs in a smaller level, so it won't take too long to generate your hierarchical level of details. So go ahead and create a project for the current engine version that you have. You can see that this is a nice small map, and it takes advantage of the one actor per file from the world partition. So if you open up your world partition tab, under window world partition, you can see that world partition is already enabled, but streaming is not enabled, so there's no streaming going on. So this is good for a small map, and it's nice because people can still change some actors here and there, and only that change will be saved because of the one actor per file setting. We're going to go ahead and make this be streamed. So let's just pretend that this is a bigger world than it is. So navigate to your world settings, and then under world partition setup, turn on enable streaming. And then it will have some settings, the default HLOD. If I go to it, okay, so if I open that, it's a simplified mesh. I found in some documentation that as of 5.4, there's a new class that works better. And I will share this link as well. In this document, you can see the important changes in 5.4. So this is really recent. So whenever you create a new world partition level, it will default to a specific new class. And here it explains exactly why that's awesome. And this is the one we'll be using. I'm just going to create a new world partition level to get all the correct settings of 5.4 and onward. Navigate to File, a new level, and then we're going to choose Open World. Okay, and then just for reference, I'm going to go ahead and save it as StackObots, maps, and then this one I'll just call it L_open world, and then save. These are all the runtime settings. It uses the runtime hash set, and it sets up one main grid, and the default HLOD layer is actually instancing, not simplified mesh. So we're going to use that because I found so far that it also was the fastest HLOD generation, and it created it right here. So we can also use that layer for our main world. I could take a screenshot and then go to the recent level, and we're going to open up our main world. You can see that here it defaulted to the way before 5.4. Go ahead and click this, and I'm going to use the runtime hash set. I'm going to double check that all the settings are the same. Okay, and then the default HLOD layer, I'm going to choose the new one that was generated. So open world HLOD. Okay, so this will just be for our first generation of HLOD. After that, we're going to create our own layers. Okay, so I'm just going to compare. So open world. Okay, the only difference is the name of the HLOD setup. So this is the persistent level, so whatever HLOD persists. So I would also check off is spatially loaded. So I'll check off is spatially loaded, and I will rename this just to persistent level. And you can see there was a lot of warnings about the actors having an invalid HLOD layer. So it's searching for this here, it's not finding it. That is because we have to set it up in our HLOD setups. This is the setting for the world partition grid size. And then this is the part we care about, the HLOD setups. So we actually have to set up our open world HLOD instancing here. So I'll just go to it, and then I will use the select asset. And then when I save, everything should be fine. This part might have been a reason why my HLODs were not generating. I wasn't using the newest and greatest runtime hash class. So if you had an old open world map that you started a while ago, you might just have to change the class and just set up all of your HLOD setups or layers right here. So what you see on your screen is every actor that is not set to spatially load. So if I go to the details of this landscape proxy under the streaming section, you'll see that it is included in the HLOD, but it is not spatially loaded. Same thing with the building or this specific room. This could probably be spatially loaded, especially if it's a big world. So I'm gonna just try to also consider this one for the world partition streaming. So I'm gonna turn that on. And if you have your runtime grid set to none, it will just use the default runtime grid, which is in your world setting. And in our case, it's just called main grid. Okay, so to build the HLODs, you can navigate to the build menu and then build HLODs, and then click on build HLODs. And this might take a while, but in my case, it didn't take long at all. And if you get warnings like this, so spatially loaded actor references non-spatially loaded actor, a lot of time how you can fix those is that you can set the actor not to be spatially loaded, or if both of the actors are spatially loaded, they have to be in the same grid square or in the same data layer. Okay, so I'll go to it, outliner, and whenever an actor is unloaded, you can just pin it to load it, or you can go to the world partition and load it, but the pin method is faster. I could just turn that off. Okay, so this one is non-spatially loaded. So I could change that one to also be spatially loaded. And then I will build the HLODs. And what's nice about building the HLODs a second time is that it will just update whichever actor changed. Unless you add a ton of new actors, it won't take too long because it will just update those ones. Okay, so we have another one. There you go. Okay, so now we have no more warnings. And if it takes a whole lot of time and you're running out of RAM or video memory, what you can do is when it's generating it, you can stop the generation and then you can find the command that it uses. You can run it from the command line. Find the line that has a log world partition editor display running commandlet, and then this is the command. I'll just select the whole line. Okay, so I copy and I paste it. This is the commandlet that is going to run. You can remove this argument here because you won't be running from the Unreal editor, and you can specify another path if you want to have your log be somewhere else. Close your editor and then copy paste this, open up your command prompt, and you can paste this and then you can run it. And this should be faster because you don't have to have the editor running at the same time. And wow, that was really fast. And if I want to know if that succeeded or failed because that was so fast, I would just go to the path of this log and see if it succeeded and what errors it ran into. Okay, so after generating your HLODs, you'll see that even with nothing loaded, you'll see the actors. So those are actually your HLODs. So if you go to your outliner, you'll see all the HLODs in that layer under a folder of the name of the HLOD layer. So if you go to your world setting, you'll see that this name matches that. It combines the actors in very specific ways. So the basis with these for generating HLODs will add actors to your project. So it may balloon up your Git storage or your Perforce storage. A tip is to only consider what you need. So if you have something small like some pebbles that you don't need to see from far, let's just have, for example, these cubes. We don't care to see them from far. What you can do is in its details, you can set it to not include component in HLOD or not include actor in HLOD. You can turn that off and then it won't be considered in the HLODs. In my case, generating HLOD instances, it definitely gave me a warning for my Git large file storage to potentially have to increase how much I pay for my data. You also notice that there's some actors missing. So if I just select everything in the world partition and load the region from selection, you'll see that the trees are not considered. for HLOD generation. So at first I clicked on it and I went to the details. It was interesting to see that it is included in the HLOD. But then I actually found that I need to go to the foliage mode. If you click on select and then the trees and the bushes, and then we scroll all the way down, we can see that they're not included in HLOD. So I'm going to change that to true, and then I'm going to regenerate my HLODs and then save those. Okay, after that is done, I will just unload the regions, and now you can see that the foliage is here. And it doesn't wobble because the generated HLOD nanite foliage doesn't have world partition offset enabled. Now for how that actually works in game, first of all, we want to preview how our world partition works. So navigate to your world setting tab, and then under runtime partitions, under the main layer, you can click on show grid preview. Okay, so those are our grids. And this is the loading range. We're just going to make the loading range smaller. So I'm going to do 10,000 times 2. So it's always nice. We can do math in these edit text fields. Okay, so you can see the loading range is here. So this always confused me a little bit. So the loading range is over there. But then in purple is what's actually loaded. So if I go backwards, you see that it unloads. And whenever it unloads the actors, it'll be replaced by the HLOD version of those actors. So I'm gonna turn off the show grid preview, and then let's go ahead and play. Okay, and then to visualize how the HLOD works, I'm just gonna search for HLOD, and then you can see at the top, show HLOD coloration. So I'm gonna turn that to on, or it's a toggle, so it could be on and off. I'm just gonna fly out. Goodbye. Okay, so you can see as I get further, the blue is the HLOD actors. I'm going to decrease that even more. Let's show the grid preview. Okay, let's try this. Oh, I'll stop this. Okay, so I changed the cell size to 7,000. And then the loading range to 5,000. As I go further, you can see that the HLODs start to pop up. So that's way less actors to load and less draw calls. Another way to preview your HLODs in the editor is you can go to lit and then actor coloration and then HLOD relevant color. Anything in green is what's considered for HLODs, and anything in red is not considered for HLODs. I was confused a little bit about the grass at first, but the grass is some magic material thing. It just auto-generates grass wherever there's the grass material for the landscape. So they're not actually actors. But yeah, so this is everything that will be considered for HLOD generation. And you can see that these ones will not be considered. Now I want to talk about HLOD layers and how to organize your HLOD generation so that it matches your project. So we're going to add all the foliage into its own HLOD layer so that in the future we can sort of replace it with imposters. I haven't figured too much how to make imposters for foliage, but I feel like that would be a huge performance gain. I searched online to find examples of different layers, and I found this super useful document with examples of what Fortnite uses as their scenario or their setups. So for example, in their Fortnite chapter 4, here's their map size, their actors, and what they use. And then the different layers they have a layer for buildings because they're destructible and it's spatially loaded. So if you're close enough, it will have an HLOD of 0. It'll be a special merged mesh and it has destruction support. And then if you go further, there's another layer for HLOD 1. And this one uses the simplified mesh to combine its meshes. So if you're past 2 kilometers, then it won't even render the HLOD for the buildings. And I'm sure that's a big gain for mobile. And then they also have a HLOD for trees. This one is always loaded and it uses just trees imposters. So either you're close enough to the trees and your world partition just has those actors, or it's just tree imposters. And then what's interesting about this is if you're making a multiplayer game, they have everything loaded on the server. So there's no HLOD on the server. But then they have streaming use in Pi to improve developer iteration, and the landscape's always loaded. That one's very important. I ran into that issue where teleporting, I would go through the world because the ground wasn't loaded. So it was nice to have some HLODs for whenever the actor hasn't loaded yet and it has collisions, but also have the landscape be always loaded. Yeah, let's go ahead and add an HLOD layer for our trees. And in this tutorial, we're just gonna keep using the instances, so nothing too fancy. I guess I'm gonna turn off my actor coloration, and then I'm gonna navigate to my world setting, and I'm gonna search for my open world, and I'm just gonna duplicate this one. And I'm gonna call it HLOD layer trees. I should call that foliage because rocks are not trees. They're also not foliage, but in this case, rocks count as foliage. So I'm gonna add to my HLOD layers and then this foliage. Yeah, so none of these are spatially loaded. We could always have more setups, or if you want to have something that is spatially loaded, you would add another setup, and then that would be maybe like buildings. So let's, for example, I won't actually be using them, but let's say buildings. Then I would say, okay, it's spatially loaded, and then I would add some layers. Okay, I'm just going to delete that. Okay, so for the foliage, we're going to just use instancing because it's fast, but it could use the simplified mesh, approximated mesh. I found that a lot of time when I was using the simplified mesh or approximated mesh, the build would fail. I still have some learning to do on that side. If you're having buildings or things that are destructible, you could choose the merge mesh, and then you could use the HLOD modifier, world partition mesh destruction modifier. What's nice about this one is it considers the destructible component. So your HLOD will also know about the destruction. That's still something that I need to dig in, and I'm not doing destruction in my game. But it's good to know that there's a way to modify the HLOD before and after they're generated. And what's nice about this new setting is that every actor is in charge of defining which layer it's on. In my case, I want to select all the foliage, so I need to load everything. And there's also a few rocks that can also be part of the foliage layer, or maybe they're bigger rocks and you want them to be to generate their HLODs another way. So I'll just select all the instance foliage actors, and then I will also select all the rocks. In the streaming for the HLOD layer, I will choose foliage. So if this was a building layer, I would use the building layer. And then when I generate the HLODs, I'll just unload everything. You'll notice that now there's two folders under the HLOD folder, and these correspond to whatever HLOD layer that you create. So I think I'll even rename that one at some point, just so it makes more sense. So this could match up pretty much with the Fortnite setup that they have. It's easy to define your different layers and set up how you want them to behave. And as far as layers go, if you have an actor that doesn't have anything set to their HLOD layer, it will use whatever is defined in the default HLOD layer. Just a word of caution, if you're parenting some things, it might not be considered for HLOD generation, but in this case it was. The next thing I want to talk about is how does this actually stream? So how does the world partition or HLODs know when to load and unload? Well, that depends on your streaming sources. So by default, after 5.3, so in that same document, the player control base class can now auto-register itself as a streaming source. So the player or the camera location already knows that it is a streaming source. But if you always want something else to be streamed, you can use what's called a streaming component. So I'm currently experimenting with that one when it comes to teleporting. I'm just going to create a new actor. So stack of bot, blueprints. I'm going to create a new blueprint class, just a simple actor. And then b underscore streaming actor, or streaming spot actor. And all this actor is going to be is just an actor just to contain this world partition streaming source. And you can preview how much it wants to load. So I'm just going to drop it in these trees at the back. Let's just pretend that these trees are so important and we're going to teleport to them, and we'd rather have that area always loaded, and we're going to make this always loaded. Okay, so the streaming actor, and then under world partition, let's make sure that this is not spatially loaded. So now when we play, and let's turn on the HLOD coloration. I already forget which corner we used. Okay, so I will add just a really tall cube, just so we know where we are. This is where our streaming source is. And now when we show the HLOD coloration, okay, so you can see that detached from the player, you can see that they have world position offset going on. So anything around this streaming source has loaded the world partition actors. So there won't be any hitch if you try to change the player position to here, because everything will already be loaded. Of course, if you add so many of these source component or streaming source component, everything will be loaded and it'll be just as slow as it used to be. Personally, in my project, I'm experimenting with whenever the player teleports, to have one of these actors to preload the area that the player is going to end up, so that whenever you teleport, it's ready and good to go. And you're not just seeing the HLODs, or worse, like your ground hasn't loaded. I'd like to do a follow-up video about the teleportation, but for now my teleportation's a bit slow because I have some polling going on just to make sure that the grid has been loaded before the player ends up here, but it should be fine when it's half loaded. I don't want to waste the player's time. There's still a lot to dig into, as in the layer types. I tried to use the same spot to gather these two sets of data, and I turned on the stat GPU, I turned on the stat FPS, stat unit, just to get more information. It's not as detailed as Unreal Insights, and this is still playing in editor, but you can already see a difference. Even though there's not that many HLODs, this is before, so without any streaming, so everything's always loaded. It's a lower frame rate. There's about 1 to 2 sometimes millisecond difference. And you can see that after, there's way less draw calls, even though there's more primitives being rendered. So you can see that the HLODs are doing their work. But yeah, in general, this was a hard one to prove with this map because the foliage is already instanced. It makes a huge difference when there's more actors. In whatever setup you make, I found that HLODs gave me back a lot of performance. My next tutorial will go over taking into the custom primitive data so that the HLOD also has the right color and the right information. So whenever that is up, I will put it up at the end of this video so you can have an easy click. If it's not ready yet, you can go and check out my custom primitive data or my minimap video for more about the world partition or materials. As always, thank you for watching and see you in the next one. And thank you so much for all my patrons.